Hello everyone. Let us discuss the process of quantization, which is the second important step in the conversion of analog signal to digital signal. I've taken one analog signal. This curvy signal, let us assume, is an analog information signal which needs to be converted to a digital signal. Now, before the process of quantization, this continuous time signal must have been sampled already. So we have just considered the entire signal once again, but this whole signal will not go into the circuit of quantization. Only the samples of this signal will enter into the quantizer. So let us quickly mark the samples that we are going to give as input signal to the quantizer circuit. So we have been showing some few samples in the beginning and then after some period of time, almost towards the end. All these pink dots are nothing but the samples that we are reading from the continuous time signal. This is done through the process of sampling. Once we get the sampled version, it is now given to the quantizer. Please remember that all these samples will be represented by nothing but the rectangular pulses of the heights equal to the sample values. We are not showing the rectangular pulses because right now we just want the maximum values, that means the sample values that we are going to have. Now the function of quantizer is to assign fixed values to every sample value which is entering into the circuit. This can be done by dividing the entire amplitude axis into smaller amplitude levels. To understand this, let us assume that VL is the minimum amplitude value which the signal will take and VH is the maximum amplitude value which the signal will take. So the total range over which the signal will vary is from VL to VH. VL can be 0 and VH can be some maximum amplitude if the signal is only taking positive values, or if the signal is taking negative values, VL can be some negative value, let's say minus 5 volts, and VH can be corresponding positive values, let's say plus 5 volts. So from VL to VH, we divide the entire amplitude range in smaller levels. We have been showing, right now I have shown a few levels. Let's say for example, this is the level number 1, this is level number 2, this is level number 3. And then let us say that this is level number 8. Now, you cannot choose any random number of levels. Every quantizer is associated with something called as number of bits that we assign to every sample value. If I take n bits in the quantizer circuit, then the number of levels that we can have, let me call it m, will be equal to 2 raised to n or 2 raised to n minus 1, depending upon the type of quantizer. So if I take the number of bits equal to 3, if I take let's say if n is equal to 3, then we may have the number of levels in the quantizer equal to either 8 or 7. So for example, let's assume we have 8 levels. So in that case, we divide entire amplitude axis into 8 different smaller amplitude levels. Each amplitude level will be assigned a fixed value, which will be the midpoint of that amplitude level. For example, if you see, all these red lines that we have drawn are nothing but the fixed values which they correspond or which they represent of each and every level. So for example, for the first level, the fixed value that we will assign is this midpoint. For the second level, also the fixed value that we assign is the midpoint. The midpoints are generally taken as the fixed values that we assign simply to have the minimum quantization error possible.